You don't always need a sign chart to determine what type of stationary point it is. Sometimes the second derivative gives the answer instantly. What is the second derivative test? The second derivative test uses the second derivative to determine whether a stationary point is a local maximum or minimum. This method provides a quick way to classify critical points without creating sign charts. Here are your 4 steps to success. First, find the first derivative. Find f prime of x from the original function. Second, find critical points. Solve f prime of x equals 0 to locate stationary points. Third, find the second derivative. From the first derivative, you'll calculate f2 prime of x. And finally, test the second derivative at each critical point to determine the nature of the point. That is it a local maximum or minimum? Here are your classification rules. A local minimum occurs when the second derivative is greater than 0. That is, the function curves upward at the critical point. If the second derivative is less than 0, you'll have a local maximum. That is, the function curves downward at the critical point. And if the second derivative is equal to 0, then the test is inconclusive. You'll need to use the first derivative test instead. And you can look at our lesson on the first derivative test in the link above. Let's look at our first example. Given the function f of x equals x squared minus 4x plus 1, we want to use the second derivative test in order to find stationary points. So first, we find the first derivative. The derivative of x squared with respect to x is 2x. The derivative of negative 4x with respect to x is negative 4. And the derivative of 1 with respect to x is 0. So our first derivative, f prime of x, is equal to 2x minus 4. In order to find the critical points, we let 2x minus 4 be equal to 0. And solving for x, we find that x is equal to 2. Now let's find the second derivative. So from the first derivative, the derivative of 2x with respect to x is 2, and the derivative of negative 4 with respect to x is simply 0. So f2 prime of x is equal to, which is positive. Since the second derivative is positive at x equals 2 and at any point, we know that the point x equals 2 is a local minimum. The positive second derivative confirms the upward curvature. In this next example, we have the function f of x equals negative x squared plus 2x plus 3. So in order to find our critical points, first let's find the first derivative. The derivative of negative x squared is negative 2x. The derivative of 2x is 2. And the derivative of 3 is simply 0. So f prime of x is equal to negative 2x plus 2. In order to find a critical point, we set that to be equal to 0 and solve for x. Solving for x, we'll find that x is equal to 1. Then we can find the second derivative. So the derivative of negative 2x is negative 2, and the derivative of 2 is 0. So our second derivative, f2 prime of x, is equal to negative 2. So since it's negative, and it's always negative, we know that the point x equals 1 is a local maximum. That is, the negative second derivative confirms downward curvature. In this next example, we have the function f of x equals x cubed. Finding the first derivative, f prime of x is 3x squared. If we let that be equal to 0 and solving for x, x is equal to 0. Now, finding the second derivative, that is the derivative of the first derivative. So the derivative of 3x squared with respect to x is 6x. If we substitute a critical point x equals 0 into our second derivative, f2 prime of 0 is 6 times 0, which is 0. Now, since the second derivative is 0 at the point x equals 0, the test fails. The stationary point exists, but it is neither a maximum nor a minimum. So in this case, you need to use the first derivative test instead in order to classify this point. Here's your challenge for today. Use the second derivative test to classify the stationary point in the function f of x equals x squared plus 6x plus 5. You'll need to find the first derivative, find the critical point, then find the second derivative, and finally classify the critical point. The second derivative test provides instant answers without sign charts. Remember the rules. If the second derivative is positive, you have a minimum. If it's negative, you have a maximum. And if it's zero, it's inconclusive. If the second derivative test saved you time, keep practicing with more examples to master this powerful technique. And if ever you need any help on derivatives, please download below my fast track derivative cheat sheet. Thanks for watching. Please like and subscribe. And remember, math success starts when you stay on the fast track.